Good morning, everyone. My name is David Breeding, as you heard, and I'm here with my colleague Matt Hines-Aldrich. We're going to chat a little bit about some technology that we've been exploring together. And yeah, AppGeo, we've been doing geospatial consulting for many years, but have a really strong developer team that has been exploring some new spaces on how we can kind of help our customers really administer their data, learn about their data, store it and access it in different ways. So we're going to start with Matt. He's going to tell us a little bit about NFPA, kind of give you a feel for their use case, because I think that's really important to us, is really understanding and aligning with our customer, and then get into this National Fire Data System project that we've been working with NFPA on, and then talk a little bit about what is serverless technology, why we think it's going to be a valuable asset, and then dig into the use case of building out NFDS. So I'll let Matt talk a little bit about what he's got going on.
Good morning. So as you said, I'm Matt Hines-Aldrich, and I work for National Fire Protection Association, otherwise known as NFPA. So you may or may not have heard of NFPA, but I can assure you that you are the beneficiaries of NFPA. So sitting in here, we have a sprinkler system that's directly over our head. And so and we also have electrical conduit. We have exit lights. We have unblocked exits. All those things are basically the bread and butter of NFPA. So NFPA has been around since 1896, and for over 120 years, we've been a codes and standards organization. So we're not a government; we're an NGO, and we don't actually write the codes per se. Groups of stakeholders, they get together and write them, and we convene them and publish those and that kind of thing. But the thing about NFPA is that for 120 years, we have been a codes and standards publisher. And we're building we're helping people build safe buildings, safe systems, that kind of stuff. National Electric Code is one of our documents. All these things, we're trying to make the built world safer. But as we, as an organization, have tried to help figure out how do we help make the more modern world safer, a big part of that is data. And for the past about 50 or so years, the well, actually much longer than that, but many fire departments, when you see them driving by, whenever you see a fire truck go screaming by with lights and sirens, whenever they go back, once they do the fun part, they do the part that everyone hates, which is enter data into and create or fill out a report. And so they've been doing this forever. And so, and there's a big national system that they feed this data into, which we'll talk a little about in a second. But this basically, this NFIRS system, National Fire Incident Reporting System, has been around since 1976. Again, and many fire departments were doing it before that, but they've been trying to create this thing. And so one of the problems with it is technology that is kind of conceptually based on 1976. And the last substantial update to this system and approach was basically in 1999, to give you a sense of how up-to-date it is. So we are working as an organization to try to figure out how to update and work broadly to help kind of make the built world safer. So just a quick anecdote. So like with just the amount of innovation in modern technology. So one of the big conversations right these days is around energy storage systems. And so how, if you're putting in these large battery banks in the 37th story of a building, how do you make sure that's actually going to be safe when things don't quite go to plan? And so, or when Uber starts making flying taxis and buildings all start having heliports on the roof, how do you actually, how do you make kind of those type of environments safe? And so what we're seeing is we're trying to, as an organization, we're trying to figure out how to basically still accomplish our core mission, which is trying to make the world safer, but at the same time, try to figure out how to make his codes and standards sounds really kind of stuffy. It sounds slow-moving, sounds kind of anti-innovation. And frankly, in some cases, it is anti-innovation. And so how do we create codes and standards, and how do we start actually, as an organization, help support this more modern world we're in? So, and so that's, as I mentioned, we're the existing infrastructure, existing way people collect data in the fire service is quite antiquated. And so the way that this NFIRS reports that they write, So the current approach causes a number of backlogs. And really, those backlogs come in from just the way the current infrastructure is configured. So, being here in New York City, when FDNY, the largest fire department in the country by considerable measure, whenever the 12,000 firefighters here in the city, they enter the report, it goes into their own local system, and it sits there until somebody in their local system says, oh, shoot, we probably need to send that to the state, don't we? And so, but meanwhile, that data is getting older. The good thing is many fire departments are starting to actually use their data, much like you hear a lot more about how law enforcement is starting to use their data. The same thing for the fire service. And so we're seeing fire departments start to use their own data. But again, they have the benefit of their own data and their own efforts. And so, so that data typically just sits in their own system getting older. Again, they may or may not use it themselves, but no one else gets the advantage of that information and analytics. And so, so they then send it to the state, and this happens in every community. There's 30,000 different fire departments in the US. There's 1 million firefighters. So there's a pretty big challenge, and that's in the US alone. And so it goes to the state, and then they sit there and they wait, because they have to wait for whatever the slowest fire department is. So they sit there and wait, and that data gets older and older and older. Then the state says, oh, about time for us to send it to the federal government. So then they send it to the federal government, and then the federal government says, oh, well, we can't really do anything with this data until we get all the states. And there's always one state or two that start kind of say, oh, yeah, shoot, we probably need to send that data in. So meanwhile, that data, again, is just getting older and older. So the current infrastructure is, we basically tend to get a national data set of fire incidents across the country about 18 months after the actual incidents have occurred. And so, and again, it's not to say that the fire departments themselves can't use that information, and some are doing really innovative work. But at a national level, in terms of getting a sense of how many fires occurred, are fires going up, or fires going down, are there new types of fires? I can assure you in 1999 to 2001, when this current model was created, hoverboards were not a thing. So when hoverboards become a thing and start catching on fire, how do we start documenting those? So it's kind of this legacy approach has been kind of a problem. And so that's why we're trying to build a new national fire data system to try to create a new approach to move this kind of forward. And so, and that's where kind of, again, this project and our partnership with AppGeo in terms of trying to build this. And so we'll talk a little bit more about this whole approach that we're using. But that's kind of, in a sense, a little bit of background on the why of what we're doing and who, I guess.
Yeah. No, thanks, Matt. And we've been excited to kind of partner and learn alongside them and really envision where that future is. How are we supporting hoverboards? You know, so, but before we kind of get into the tech, the specific use case, how we're leveraging some of these cloud-based resources, I want to just do a quick primer on serverless technology. Who's ever heard of serverless before? Raise your hands. Okay, we have a few in the crowd. Ever deployed or written any kind of function-level code at all? Okay, you know, a little less. But so I wanted to kind of quickly, for those that maybe are less familiar, just kind of go through what we're kind of think about as a level of abstraction that's been happening over time. Where one, you know, here we have data systems and servers and mics kind of stored here on premise, your data center. You know, slowly that type of idea has been shifting to like infrastructure as a service, where that technology now is managed by someone else. I don't really have to be in charge of whether it's plugged in or not. And then, you know, if we think about CARTO, platform as a service, they're delivering a tool. They're managing that infrastructure. You pay them to give you access to that platform. What we're seeing now is this next level of abstraction, where essentially, you know, it's abstracting all the way down to a very small unit, down to specific functions. All of that, you know, as we heard of this transition, all of that infrastructure, I just want you to run this thing. Just run it on your machine, do this one function, be able to do as many of those functions in parallel as we want. And you know, so again, similarly, just thinking about these terms, these monolithic applications. It's one massive stack running on one big system. You know, we start getting containers like Docker and Kubernetes, and you know, these microservices, this progressive delimiting of individual pieces of an application. These functions as a service is kind of what we're trying to leverage. We're thinking, or it's runtime as a service. Some of the nomenclature is still like developing, but that individual unit of a function is what we're kind of leveraging to support what NFPA is doing. And when I say serverless, there's still servers here. Don't be fooled. It's not floating out there on a hoverboard anywhere. There is a server, and it's running. We just don't want to care about it anymore. We want to just do our work, empower our development team to kind of really think about the solution. So we've been thinking about serverless and been leveraging it in small ways in our own infrastructure at AppGeo, and really kind of why are we doing this? Because we really think that at the end of the day, it's going to improve our clients' workflows. Make them, if they're happy, we're happy. We want happy customers. We want NFPA to really understand their data. We also want our development team to be focused on those solutions. They're happier. They're these little units of functions that we'll talk about. They're either working or they're not. They can attack those challenges where a little function isn't working, and supporting that again in parallel is another thing that becomes more easier because you can go and focus on that particular piece of the process. But high level, it's running on somebody else's server. It's event triggered. We'll talk about some events in the workflow that are happening in NFPA's use case. Really liking just outsourcing, not having to think about the hardware. Billing is really a function of what you're running and how much you're running. Like that, just charge me for when it's running. I don't want to have it on 24 hours a day and pay at that model. It encourages you to write efficient code. And so it's kind of how you think about developing these applications is kind of changing, and security is also managed by someone else. So I don't need to be concerned if we are storing sensitive data. That's managed by a larger organization that has really developed kind of systems in place. So getting to the use case that we're really excited about, talking about this national fire data system. And Matt already alluded to this process, and this story arc is really, in this project, is focused on incidents, the NFIRS data. So that was the use case, but it has broader application. We want to store all of NFPA's data, but for this project, we're really focused on NFIRS. And you have a fire, it gets stored. That whole process takes some time, and we wanted to increase that. We want to get that data out faster, get it into a platform that allows you to interrogate it and work with it. And wouldn't it be great if that was live and available and always up to date as that new, as the progressive New York City Fire Department is deploying their data every day, their run sheets go out, the system can accept it. Or maybe you have other varying levels of participation in delivering data, but that's getting fed into this system that is ultimately delivering content to help decision makers. I don't know if you have any adding to that. I like your CD example this morning.
Yeah. So the CD example is that one of the biggest challenges, again, when you have a very somewhat dated legacy system is somewhat dated legacy ways of sharing data. And so one of our biggest challenges when we get this big federal data set for all the fires in the US is we get it in a CD, and the first challenge is trying to find a computer in the building that still has a CD-ROM. And so I had someone from the federal government just the other day reach out to us, and they were asking, they're like, is it serious? They're like, we keep reading this thing saying that the way they share data through CD is like, is that accurate? Yep. And so but one other thing I'd add here is that, so as we talk about incidents, and again, this is, again, it goes back to this whole thing of every time you see a fire truck go screaming by, that they're writing a report. But the other part here is that, and this is really where some of AppGeo stuff, and also, again, where some of the stuff around CARTO can be really helpful, is that we're also trying to change that mentality that, like, historically, fire departments have shared incident data, but they do many, many other things. And so there's many activities. And again, it goes back into if you're the fire department, try to, in a sense, justify your existence or try and demonstrate your value to your community. If you only talk about and only are able to share and show the incidents you respond to, the problem is what's actually been a great thing for us as residents, we're actually much safer than we were back in the 70s. There's been a substantial reduction in the number of fires. But if you're that fire department trying to justify your existence when your number of fires are going down, it's not that they're sitting at home twiddling their thumbs and all that kind of stuff. But they're actually doing a tremendous number of other things, and they're documenting it. The problem is they're not documenting it in a consistent way. And so when we start looking at all these other activities they're doing, we start trying to figure out how we would actually then start mapping them. Yeah. The challenge is some people are doing it in Excel spreadsheets, some people are doing it in hard copy forms, some people have databases they've created or apps. And so we're trying to create a much more kind of dynamic way using some like data lake technology. But again, it goes back to this of spinning up functions as we need them. Because again, when someone starts saying, hey, I have all these photos that I want to share with you, we have to figure out, our system wasn't designed for photos, but we can actually spin up that instance pretty quick. Yeah. And so, so I'll pass it back to you, Dave.
Yeah. So following right onto that, we want to talk a little bit about what did we build? NFPA had been working with Amazon, and so we decided to align with them. We are very familiar with all the cloud providers that are out there. We work with Google, use the Google Cloud Platform. Azure, a lot of these companies are already ready to kind of serve and run these functions that we'll talk about a little bit more. One thing to be considered of is there are vendors, and they are creating their own little pieces that run these types of functions. So just be cognizant when you are going out into the world and you are maybe running these systems that you should understand that there's a variety of resources out there, and we're kind of continuing to monitor that and make sure that we really understand what the value that each platform can provide. And it's on demand and powerful. That's what we really love. You have the horsepower. It'll expand. I want to run in parallel. Thousands of functions, great. Turn it on. I'm going to pay for it, but it's going to be right there when I need it. And so I'll get into some more details specifically about just some of the building blocks. Serverless.js, a node framework, which is really where we write a lot of our code. We write the functions. We define some of the usership logic. And what we really like about that platform is that it can deploy out into multiple clouds, whether it's Google or Amazon. So that's a way that we've been really exploring there to make sure that we're ready to move and migrate when the new use case comes along. Getting into some of the more granular elements, S3, or Simple Storage Solution, where the data exists. We're leveraging that component of the Amazon platform. The IAM resource is essentially identity management and access. You never want your functions to go rogue. You want to be in control of what they can do, and you want to, just as a best practice, make sure you're managing them very effectively. Lambda, consider it the function runner. It's the thing that's going to go and run and be deployed out on this scalable solution. It's going to, whatever the logic is or whatever the function that you want to deploy, that's what's doing it. Glue, we can think of it as just the mapping of all of these files that come in to Amazon. It knows where they all are. So when you make a request via Athena, you can access it and communicate in a common way. SQL is a very common way to access data, and so that resource really allows you to get at the information. I don't want to dwell on this, but this is the workflow starting in gray. The data comes in. We know who you are. We know you're allowed to deliver data. Within the cloud box, all the green, these are the functions that are firing. They do a lot of different things. We'll talk in more detail about them. Red is just when users get involved, when Matt and his data scientists want to get at the data and see what's in there, evaluate the quality, or you want to plug in other users that might be doing their analysis via business, other business kind of questions that come through. They're coming in and accessing your data. And then ultimately publishing. We want to get it out, BI tools, LI tools. Publishing is another part of that workflow. But we're going to break them down, talk about this ingest piece, some of the processing, that access, enrichment, and so on. And so you'll notice these in the top right-hand corner of the slides just to keep us on pace and understand where we are in the workflow. So Matt alluded to it earlier, types of data. We have very structured NFIRS data. It has a defined schema. That's a CSV normally that comes in, and we can store that. Pictures, we can store that. We can store unstructured data. So there's a lot of flexibility when you use a bucket. When you use an S3 bucket, you can store lots of information, and it'll be ready to accept that. I mentioned schema. We can help the system understand the schemas we're looking for. But it'll store other data, and then maybe in the future you can define a new schema. And so it can kind of understand what's going on or what you want to try to do with that information. Affordable, it's scalable. It just really makes a lot of, it allows you to not be caught and hung up on some of the, how am I going to store terabytes, petabytes? Yes, there's a cost, but it's very affordable. And for many use cases, we're seeing that that's not a huge concern. You're not editing this data. It comes in and it exists that way in perpetuity. A lot of the functions and queries that are happening downstream, that's bringing together data in interesting ways, but it should be known that you're not adding records to that data. You're maybe creating new data that exists alongside in storage. And so that original state being preserved is really important because let's say the use case changes for Matt down the road. I can go run it all again against every data set that's ever been delivered to the system. But really the meat of this, the really cool part of it, where Neil Patrick Harris is going to help me kind of explain what's going on, are these Lambda functions. When data comes in, a file, we just walk through this, a file gets deposited in S3, and Neil is waiting for us. Neil is waiting for that event to occur. Once that event happens, he knows what to do. He's going to wake up and start on, well, what type of file is this? If we just think about getting a file in our inbox, let's say it's a zip file. Well, I want to put it on my desktop. Well, what's in it? OK, yeah, I know what this is. This is a shapefile with a projection, or it's a shapefile without one. Well, that's a kind of one of the functions to check whether it has a projection file. If it does, it goes here. If it doesn't, it goes there. And again, if you just think about these functions, these little pieces all firing in series, that's what's happening. We're building these step functions. We're defining the logic for the specific use case to really build up a resource that's going to help us understand and ultimately get at this submission, get at this data which is stored in S3 buckets. What's really important is being able to access it easily. This SQL access is very common for users. They've been interacting with instantiated databases, RDBMSs for many years. And so we really find that being an important characteristic of the solution in this mix that we've created. Just to mention some of the, once all of those processes and all those logic has occurred, it ends up in the final, like, we know what to do with this. And glue is the connector, as I mentioned, to make sure when I make a query, when Athena goes and say, hey, I want this table with this data that has these characteristics, it knows how to go aggregate it from all of the millions, n number of files and pull it together to deliver you your table. And if you take nothing else away, what we found to be very kind of valuable is once that query is fired, it's going to cache a CSV in a bucket. It's CARTO, we can use the sync functionality. We can get it into the platform. We can connect with that S3 location. And we're excited about that. That allows us to store this have a very flexible data storage system and processing system, and then deliver it to ultimately enable data scientists to get at it via SQL queries. So this is when Matt comes in. His analysts want to get at the data. We're thinking about the whole variety and ecosystem on how we build various interfaces for different levels of access. You have your developers that might just be updating that serverless code. They want to deploy new versions and new functions. So that's one type of avenue for access. There's also IT administrators that as Matt and other people are defining new use cases, new data formats that might have been stored in this workflow, they want to make sure that only the right people and only the right parts of that data are accessible. Obviously, we're concerned about potential sensitive information associated with firefighter deaths or with actual casualties associated with fire. So we're thinking about really controlling access and making sure that's well defined. And then obviously the analyst that wants to go plug in and create these value-added processes. The metadata is a really kind of important piece of these functions where, when was it submitted? Who submitted it? What level of access did they have? What fields were filled in or not? Data, how dirty was the data? You can set up metadata to help you bucket this. So Matt can come in and say, I don't want to put a state on the spot, but state X is really not doing a good job. We look at all the data they've been submitting over time, and they just aren't really kind of providing that core data that we're really trying to run this analysis. Maybe we should reach out to a state rep or whoever our contact is to help make sure that they can, what's the barrier that's not allowing them to actually collect that data? So that's really that access, that top level coming in and looking under the hood, obviously within the NFPA organization normally. The next step, I want to talk more about what's a value-added process. Whatever it is, we talked about the data coming in and the events and the access via SQL. Whenever you're going to do this enrichment, for example, geocoding, that would be an example of a enrichment process. But we're not adding to that data. We're reading in all of that data that may have locations, addresses, for example. And then we're going to run this enrichment process that's going to create new data. It's a new table that's stored in your infrastructure, but there's a defined relationship back to those initial records. So when you think about it conceptually, edit is a very common way that we think about, I'm going to add a new column, I'm going to add a new record. That's not really how this is working. It's creating a whole new data set, and when I want that new output, when I'm firing my SQL query to get it to CARTO, I'm going to do a join, and because we have the horsepower of this serverless infrastructure in Amazon or Google, we can create that. And so what might have been what is still a very intensive process, and we still think hard about how we're going to, when we're defining these joins, it allows you to do some new things. It allows you to store your data in new ways and get, and read this information, create the new content, and gain access. And we hope Matt defines some more use cases for us so we can continue to build some cool and interesting enrichments. Like, for example, the service areas is something that we've been talking about creating. I don't know if you want to talk a little bit about how incidents might help us in that respect.
Absolutely. So one of the challenges is also worth noting that my colleagues, who I like how you describe them as my employees, but Mohammed and Fred are here. So they're two of our data scientists in our team. And so we have, and that was one of the things when we came into this project. I inherited this grant-funded initiative, and they kind of came with this idea. We want all the data. We want it, like, we don't really know why. Okay, that's a good way to start a project. And so because part of that is we just didn't quite know what was in the realm of possibility. And so one of the things we started realizing very early on is that a lot of our analyses are based on what are the service areas, or what does the actual territory of each fire department look like. Again, it seems like a pretty easy thing. You have one town, one fire department, except for when you don't. So in New York City, it works well that you have one city, one fire department. Although there is some actually around EMS. In fact, there's a volunteer EMS agency just down the road. It's part of the Hasidic community. There's a lot of other parts. And so in other places in the country, there's different, you might have one town and multiple different fire departments. You might have one fire department that covers multiple towns. And so, but a lot of our analyses that we do in our big annual reports and what have you, based on this. So, but the challenge is nobody actually has a national data set of all the fire departments. We all know, we know who the fire departments are. We just don't know quite where they cover. And so we're trying to, and in fact, Fred is kind of spearheading this initiative on our side and working with some of the folks in AppGeo as well at times in terms of figuring out, can we use these incidents and geocode them and just basically extrapolate that if you put a few thousand incidents or a few years worth of data onto geocoded on a map, can we just do a convex hull polygon around these around the incidents and then potentially snap them to natural boundaries? And so as one way of, again, of trying to get at this. So this is kind of this, we have no idea at this point. We have plenty of ideas. We have thousands of ideas. We have endless ideas of what we could potentially do with this data. We just haven't quite figured out always a defined use case. And that's just one that we're working on kind of currently as we speak.
Yeah, and as we think about that use case creation, and once Fred gets in there and defines it, then it can be fired as a function. We're going to build a new Lambda function that's going to go run that process, create that output, and then when I want to do my report at the end of the year that says, give me all the service areas and aggregate by XYZ, we write our SQL query, and now we have some value. Now we put it in CARTO, we put it in a LI tool, we pull it out in a BI tool, whatever it is. But that's this process of enrichment, which use cases are first, solutions and kind of that spearheading on the analyst side to really come up with what's working. And then now let's make it repeatable, so our analysts can go and create the next value-added process, and that this system is ready to continue to create value over time.
If I can add one little extra bit here, one of the things we're also finding is that when you ask a fire department, some are data savvy, some are not, of what would they want to do, or what could they do, or hey, can you share that data with us? They're, oh yeah, we'll get to it. Or oh yeah, maybe we're not quite sure. Then if we create a convex hull polygon and say, hey, this is your territory, they're like, no, it's not. Well, let me send you the real data. All right, yeah. Fantastic. And so there's, or we create something, or we start getting this data and say, hey, this is an analysis we came up with. They say, oh, well, you could do it better. How about this? Okay, what about when we asked 6 months ago, hey, do you have any ideas? Well, it's funny, once we actually start getting that data, we get some ideas, we start putting stuff out there. Amazingly, people come up with great new ideas, and that's really kind of, we're kind of seeing the development of these use cases kind of come iteratively. And this is why, again, a flexible approach that allows us to kind of build and scale and take things down and adapt and everything. Really, because if we had to go back to our IT or some of our budget folks and say, well, actually, so we don't actually need that server after all. Our bad. And yeah. So it's really just kind of goes back into this whole idea of, as we build iteratively, having something that allows us to grow and collapse as necessary really is really invaluable.
Yeah. and we're excited. We're excited to hear more about it and continue working with NFPA and kind of how do we get the data out? How do we extract it? There's lots of ways that you can format things. We've heard about data streams here at the conference. And we're thinking about how do we stream out of this platform. We heard about the copy functionality where you can start streaming out of your Postgres database. In that workflow, you would have to take that CSV and maybe populate a Postgres database and define this can be another part of the application that we could plug in to deliver to CARTO in an effective way. Make sure it's staying up to date. That cache CSV I mentioned, the one thing, that is one way. Connect to it, sync. The volume of data is a question. Will that be, you need to really think about that sync function and think about the volume of data that you're requesting from the system. But that's an option. That's today you can do that. And so we're really excited to hear about CARTO and their integration with Hadoop and kind of Hive. And there's Amazon products that they're kind of leveraging for connections. So we're watching and listening to see how all of our partners are playing in this space, thinking about spatial at scale. How do we really make this performant? How do we help solve our customers' problems and be flexible? And honestly, if you do need to create a flat file, there's lots of options essentially to get out of this system, to query from Athena. And I've already kind of hit on it a little bit, but serving your data, thinking about the tools that we're using. Obviously, CARTO is one of them as our LI tool. Or in a BI perspective, we want to kind of extract data, and you can actually connect. There's a platform called NIME. It's an open source kind of, we would describe it as BI data workflow creation. And NFPA has been spearheading building these workflows, learning about their institutional kind of processes, making sure they're repeatable, making sure that this data comes out and can funnel right into those workflows that people have been doing in Excel for a long time. So thinking about that flow of data, serving your audience, whether it's from an efficiency standpoint or just from a visualization standpoint. So there's really kind of bringing those partners in, whether they're internal or it's the government and external, and they want access to this valuable data. We can control that access. And just to talk a little bit about what we've done already with CARTO, before we even started the NFDS project, I was working with Matt and Mohammed and the team to present NFIRS data, the CD. Yeah, we got the CD too. And so we were able to load it up and get it into CARTO. And we created an interface that leverages that underlying CARTO technology, that speed, the rendering, and we built some custom kind of filter tools, similar to some of the builder tools. But we have internally, our development team can create those very specific features and functions that NFPA wanted to put outwardly to the public, which I think it's deployed and available. Yep. If users want to go take a look. We're also helping NFPA explore other areas of their business. This is a screenshot of Code Finder. Matt mentioned how codes are critical to their workflow and their business, and so we wanted to map it and provide easy access for users to drill in, well, what is the code here? Whether at a state level, what's currently adopted, what version, because these versions in this iteration, how up to date are we? So this was just an easy way for people to ultimately get to the book that they need. There's hard copy. I don't know if you want to speak more about Code Finder or not. I just wanted to touch on it.
Yeah, just very high level. So, so many municipalities, it's easier, and probably thankfully, many municipalities say rather than having the elected officials try to figure out how to write a fire code, they actually say, all right, well, we're just going to adopt this book, and that's how a lot of this works. And so a city or a state or what have you will say, all right, we're going to adopt the National Electric Code version 2016 or whatever it might be. And so, so then the new version comes out, and it's up to the states whether they want to adopt the newest version. The problem is some states choose not to adopt the latest version. Sometimes it's easier for them, or they don't have the political willpower, or it just doesn't fall in the right cycle. And so sometimes they're many years out of date. So you might go to one state or one municipality, they're using one version of the code, and another one's using a more modern one. I mean, I heard just recently we have I think it's the boiler code. We have 350 codes and standards. But I think it's something about boilers that in California, they're still using the 1973 version because they just never felt like updating it. And so, but as an organization, we're trying to get some intel in terms of who's using what applies, and so this was a great way to visualize that and using the kind of CARTO platform because we've been trying to get our hands on this for many years and trying to illustrate which state do we need to focus our efforts to help them kind of adopt the new code, or who's using what, and for all kinds of stuff, for sales projections, if nothing else.
Nothing like keeping up with the Joneses. What are my neighbors doing? Oh, they're already ahead of us? Like, we don't want to be falling behind. That visual representation of it could be another compelling reason for people to take action. So that ability to drill in, the speed of CARTO, to get at that data, to parse it, and maybe NFDS stores code finder data, and as it gets updated, it just gets passed to the application. So there's lots of flexibility here, and we're excited to be able to kind of come on this data journey and kind of deliver a compelling solution. But in closing, is this the future? Like, we should be doing serverless for everything? And my answer is no. Functions, these Lambda functions, they can run for a certain amount of time. They can store a certain amount of information. I think it's like 5 minutes and 500 megabytes. Sometimes you need more time. Sometimes you need more storage. Sometimes it's a very intensive process. There are solutions that are still really valid. However, I think we should all start thinking about this technology from the on-demand aspect, the scalability aspect, and kind of just how functions can be blended in to either streamline your code, kind of still in this microservices kind of trend, how we're breaking things apart, and just fitting together a compelling service that will really support the use case. And spatial operations at scale is what I'm really excited about, what CARTO, and everyone in the spatial community are thinking about. How are we going to solve this? As your data sets grow, millions, billions, how are we going to do that? The underlying Athena technology is based upon a Presto database, which Facebook ultimately started creating in 2008. What I'm excited about is they have spatial functions built in. So all of this separate data, we can fire spatial intersects and buffers. And I'd call it spatial light. It's not the full Postgres stack that CARTO has. But when you think about the volumes of data and being able to execute spatial kind of workflows in that environment, create that enriched data, I see that as a really valuable development. And it's one that we continue to watch. Google's cloud platform, they're also thinking about how to do this same thing. I think that'll be something for us all to keep our eyes on in the future. How are we able to scale? And that's what this is kind of a foreshadowing of what we can do. But again, understand the tech, understand your use case, because there are fringe cases which are still challenging in this space. And finally, the focusing on solution. We want to be focused on what NFPA is trying to do, not worrying about our servers, not worrying that it's going to go down. I want someone who's really good at that. Amazon, Google, Microsoft, I want them to manage that. I want to create a valuable solution for the customer. But I really appreciate your time, CARTO for giving us an opportunity to speak here, and obviously Matt for bringing his expertise to the table and kind of providing some context to all this good work. So, yeah. Thank you.
Thank you.